So let's look into the next problem. The question is, consider a circular turn on a highway. So this is your circular turn on a highway where angle of banking is more than the angle of repose. This is your angle of banking, theta, and it is being said that theta is greater than angle of repose. A car on this turn can move with a constant speed v0 without help of friction. Taking advantage of friction, it can achieve a maximum speed Vmax, but cannot reduce its speed lower than a minimum speed V minimum, V min. So which of the following conclusions can you draw from the given information? There are 4 choices given. So you have to draw the conclusions which all are correct. So these data are given. When a car takes a turn on a circular path, it experiences a centrifugal force which will push the car away from the center of the circle in which it is moving. To avoid that, on a circular path, banking is done. Banking is done means a slope is given. So that angle theta, angle of banking, is greater than your angle of repose. So once on such kind of circular path where the banking is provided, the car is moving, and we think of a speed, and at that speed the centrifugal force is so much that its component along the slope in the upward direction just becomes equal to the component of gravitation force along the slope in the downward direction. So if it is equal, one force is acting in this direction, one force is acting opposite to it, and both are equal in magnitude, so it will cancel out. So there is no force which will try to pull or push the car. So there will not be any friction force. So at that time the speed what we say is given in the question as V0. And we know from the equation that V0 will be equal to square root of G into R tan theta, where G is the gravitational acceleration, R is the radius of curvature of the path along which the car is turning, and theta is the angle of the banking. So this you know. Now if we try to speed up the car more than V0, So your centrifugal force will increase. So component of centrifugal force up along the slope will increase, and it will be more than the component of gravity force which is acting down along the slope. So the car will have a tendency to slide up. So a friction force will start acting on the car in the downward direction along mg sine theta. So again these two forces will balance. So in that case, but this speed what we are talking about to increase, there will be a limit. If we go beyond a limit, because friction force, you know that it is maximum mu into n, where mu is the coefficient of friction and n is the normal reaction. So once the centrifugal force becomes so much that it becomes greater than your friction force mu n plus mg sine theta, the car will slide up. So there is a limit to increase the speed. And what is that limit and what is that speed? That speed we call it as Vmax, and Vmax is given by where theta r is the angle of repose. Similarly, if you reduce the speed of the car, your centrifugal force reduce, the component of centrifugal force acting up along the slope will reduce. So your mg sine theta will be greater than your component of centrifugal force up along the slope. So car will have a tendency to slide down. So friction force will act upward. So it will add up to your component of centrifugal force along the up direction, and it will nullify the, or it will become equal to your mg sine theta. So net force along the slope will be 0. But again there is a limit, like you cannot reduce the speed. You can only reduce the speed to a limit till the time there is no sliding happens. And that is the speed that is called V min, V minimum. And V min we know is given by this equation. From the question it is given theta is greater than theta r. If you add angle theta minus theta r and theta plus theta r, take the average of these two. Theta, so theta is the mid angle between theta minus r and theta plus theta r. So it means theta is greater than theta minus theta r and less than theta plus theta r. So if you take the tan of all these three, tan theta plus theta r As you know that between 0 to 90 degree, the theta increases, the angle increases, the value of tan theta increases. So the relation will still hold if we multiply all three terms with a constant, positive constant. That is GR. The relationship will still hold. Then we take the square root of all these three terms. So what are these terms? If you add V minimum to all this term, this relationship will still hold because V minimum is a positive quantity. V min V naught plus V min to V min. Now if you take these two terms and try to evaluate. So your V max plus V minimum, V naught plus V minimum. If we replace V minimum by V naught, we are not very sure what way the sign will change because we know only that V naught is greater than V mean, but how much is not known. So there will be two cases. One case can be when we replace V minimum by V naught here in this expression. So this may be less than this, maybe, but not sure, depending on V naught and V minimum. So in that case your V naught will be less than 0.5 V min plus V max. This is situation 1, case 1. In the second case, maybe this V naught plus V naught when we replace V min by V naught is greater than your V max plus V minimum. in that case your V naught will be greater than 0.5 V min plus V max. This is the second case. Third case can be when we replace V minimum by V naught, it may be equal to so V naught will be 0.5 . So this all cases are related to the value of V minimum and V maximum and V naught and the differences between them, how much difference they have. So now we can go and check the conclusion in the question. Question has V naught less than 0.5 V max plus V minimum. It is having this also, it is having this also. So our case 1, case 2 and case 3 are satisfying here. But nothing has been mentioned with this conclusion that what is the condition. So condition is not given, so we cannot say that A, B and C are correct. Again, your V minimum, V maximum is depending on your angle of repose. And angle is repose is directly related to your coefficient of static friction. So D can also be opted as correct. So in this question, nothing firm can be said that which option is correct. Because every answer is conditional. It is associated with a condition. So unless we know that condition, firm conclusion cannot be done. Any difference in opinion is welcome. Thank you.